Hi, I'm Ben-Zeev from JPMorgan, and today I'm gonna speak about how we go fast to production and don't break things, and work with our monorepo. Um, so I'll skip the agenda as but we'll go over all things anyway. Um, so a bit about JPMorgan. JPMorgan is not recognized as a tech company. It's a financial giant. But in this field, technology is a competitive edge. JPMorgan processes large amounts of data, huge amounts of payments every day, where technology is the differentiator between the companies, and trust is very important. So we JPMorgan tries not to lose payments or risk data. JPMorgan has many offices around the world and also technology offices around the world with many developers, not only admins and IT. There is a lot of development and technology going on, modern things. The office in Israel is rather new. We are more than 100 developers here, and there are many new opportunities and new teams popping up all the time. So if you're interested, you are very welcome to check that out. So Athena, this is the platform I'm working on. It's a platform for financial applications used for pricing, risk management, analysis, trade management, and many more. It's Python, or 95% Python, and more than 1,500 developers work on it. It has a very special development model for rapid changes to production, and it really makes the developers part of the business, not something that you change the code, throw away. Small incremental changes all the time to production code, something like 1,000 changes a day, where the developers can impact what's going on and be part of it, not only be some kind of a service that people use. The applications run on Windows, Linux, cloud, on-prem, many places, and let's talk a bit more about this subject. So continuous delivery, how this works. Usually someone writes code, then we have a review process. The code goes into version control. Now we can imagine maybe a merge to a master branch. Then this whole code is being built together and put together, being tested. Once it's good, we deliver to production. We move the code from one place to another, to the target environment where it's supposed to run, and deploy it, start a process, restart the process, do something, launch a container. If something goes wrong, we usually go back, maybe one step or maybe all steps, and start from scratch. Now, continuous delivery is currently considered a rather standard thing because its time to market makes a difference. It brings user satisfaction up, developer productivity goes up as you can be done with a task and not wait for the production release. It does cause a fear of change and stability because if someone works with a waterfall methodology or releases to production twice a year, maybe you test your code for more than a month with some kind of a code freeze. And this change requires some understanding, but also you can tackle it with, if you are built to release code every 6 months, it will take you a long time to fix something if you forgot it, if someone didn't pay attention. if you have a very fast continuous delivery process, maybe you can fix it rather fast. In Athena, some things can be fixed in minutes. High resilience on automation, reliance on automation, as if you want something to go fast, you need it to be automated. You need to be working at the middle of the night, on all the time, and very fast. Automated things often work fast, or can do things in parallel that a person cannot do in parallel. Well, it might be tricky on distributed systems, as you need to different revisions to know how to talk and communicate with each other, and maybe the revisions are slightly different, and there are many ways to tackle it, different like revisions API and things as such. And a monolithic code base is not such a standard like continuous delivery, especially not together. But it doesn't mean they cannot work together. So a monolithic code base, or mono code base, means that all the code is in one single large repository. And we do base our development on a trunk-based development. It means like there's one important branch, it is production, or in other places you might call it master, but this is what runs. We use small incremental changes, very frequent. You don't have to use a very large change. We do use branches, but in a kind of a limited way, and we have rather like a few options how to use them. And we do think that using feature toggles in order to develop some feature in production when not everybody can see that it works, and then expose it at once, can be sometimes a very good way. So small incremental changes, but one big change of the feature when you turn up the feature toggle can work well. A monolithic code base. One thing that we see in JPMorgan, that transparency drives quality and collaboration. If everybody can see my code, I will make sure not to write an embarrassing code. And also it will lead to collaboration, as my code could be reused. If no one can see my code, how can someone reuse it? Well, a single revision and version of code makes life easier. It's easier to communicate. It's something that we talked in the previous slides about, different revisions of code. If I have a single revision in production, it will be very easy for it to work with its own. You will know what's working on the other side, on the back end, with your code. And also, if it's in the monolithic code base, it's not like you have different microservices loading a different revision of your code. You don't have to support multiple revisions, definitely not many. This all requires investment in tooling, as monolith code base is not really something that you use everywhere, and every company who uses it has some of its internal things, and managing a very large code base requires hygiene and some governing in order to keep standards and things working, and things, and maybe people not doing too many crazy things when they are not expected to. Well, currently I talked about continuous delivery, but I didn't speak about Python at all, and we're in Python conference, so let's mention Python a little bit. Python is very different from C++ and Java. You don't need to compile the entire code base. Compilation of Python can be from a py file to a pyc file. Just change one file and you change the behavior. We focus our main efforts on code review and testing, and we believe that this makes the code and product better. Models can be deployed individually. It's almost the same as the first bullet, where you don't need to change everything, or you don't need to pack everything together. If you change one file, the application will work different the next time you load it. You don't need to create one big executable DLL, SO file, Java file, jar file, WAR file, whatever, and pack everything together. You can just change one individual file. And yes, there are a lot of testing tools and mock tools for Python, which is a widely used language. So if modules don't have to be loaded from the file system, we can also use a distributed key value store. Think about something slightly different to or similar to Redis with a key value, or an object store where the key is the file name and the value is the content of the file. It can simulate a file system and do many interesting things. So this is the previous slide, but if we apply this to Python, we can actually drop a few phases, which can lead us to a different place, especially while talking about when considering continuous delivery. One of them is the build. If we don't need a big build, we just need to put maybe the new py file in the code. During the build process, we need to change just one file if the change is in one file, maybe 10 files if the change, and we do promote and want small incremental changes. So let's say I change 10 files. So changing 10 files is not such a large thing, can be done rather fast. I don't need a large build or some dependency management around everything. Just change these 10 files in production. If we do something slightly more advanced, maybe take these 10 files and create a PYC file for them. They'll even be compiled, and we'll save the action of them being compiled again and again during runtime. And well, if considering an object store, delivering the deliver phase becomes trivial. In what way? It becomes trivial as it's just a single write to a database. It takes a second, and the code can be lazy load or load remotely from each client who uses this. This becomes really simple and easy and fun, as in a second I can update my code and change the behavior of 10,000 servers using this, and even more clients. These two things and having a slightly different revision control or version control than Git leads to the fact that in Python not everything has to be built together, so we don't have to merge everything together. Not every change has to be merged. So if we organize our code in such a way, we can run many of these processes in parallel. So my change, if I don't change the same files as my colleague, can work in parallel, and this can be parallelized, and we can make many changes. So we have a slightly shorter pipeline, and it becomes very powerful as we can run many of these in parallel. Well, a bit more about how it looks like. Well, we have many DBs synced around the world, one in London, one in New York, one in Tokyo, and in more places. And each model has its key, well, the name of the model, and the content of the code. Well, I believe that most people who saw Python before understand what's going on here. It's just simple logic that print world or PyData. But let's consider a change. Someone makes a change. We enter a phase like this. We have our change and we add a timestamp for it. So let's imagine that instead of printing PyCon, maybe I'll print JPMorgan. I'll say, hello, JPMorgan. And in this case, let's consider why this timestamp of the change is so important. When making many changes, first, it helps us to avoid some main thinking point of everything. The second thing is, while using Python locally on your disk, if you change one file, you will start a new process and you get a new behavior. But if you already have a running process that imported that file and you change that file during runtime, the behavior will not change. And then if you maybe will import another file during runtime that was changed at the same time, you might get an inconsistent mode. That doesn't happen a lot when you're working on disk, but if you have a remote storage with more than 1,000 developers working on it, things might change. So we use timestamps when starting an application. We access and load the code as it was at the time we began the process. We started running it. And sometimes time is our main revision. You can revert to a previous time, maybe not a previous revision, as in continuous delivery, many revisions. Sometimes you don't have a revision number. Well, and how does it work on a usual day-to-day basis? Well, I make many mistakes and typos when working locally, so I cannot write and type to production all the time. I need to test myself. I need to add automatic testing, and I also need to run things locally to see how my code works. So we use some kind of a layering model, which means all the code in production does not have to exist on my host. It can be lazy loaded. If I'll need to import some file, I can load it and run it. And if I'm editing a file, I need to load it locally, edit it, and then run it. So it's very simple to think about it as a path appending. Well, if something is locally, it's in the path before production. And also some might think about it as caching. So if you have it in your local cache, you use your local cache and then fall back to production. So for each code which is loaded, you start from top to bottom. If I have A in my area, my developer area, developer layer, I'll take A, but it's not here, as A would be applied to the runtime. But as I changed B, I will use B from my area and not from production. No merges are being done in this process. It's just what's before in the path, in the query for loading the code, will be there. Therefore, I can edit my code, and once it's ready, I can push it to production. I will go from my developer layer to production. This also leads to some interesting behavior that sometimes people called it some kind of automatic rebasing. The changes that you don't make, which are applied to production, are synced all the time. You always take the latest code from production. You don't update, you don't sync it, you don't pull it, you don't fetch it, you don't rebase. It happens as it's part of this query. If I don't have a piece of code, I take it from production, and it might be updated rather frequently by other developers. this layering model can be applied with more than one layer. Maybe the second layer would be made for a team or a feature with a few developers working on it. This is the equivalent of a branching model to ours, to our system. We don't use branches, we use layering. And it supports very well small and incremental changes. So the good things about this system, and another thing I didn't mention, as this Python is special, it can lazy load code. We have changes in Python or in our client. We can do special import and take it from a database. So we have some things locally. You can call it the client release or the binary release, as it's binary, and the code on the right is non-binary. It's taken from a database. It's using the web. One thing that we can use this for is for testing, as if in Git you have trouble in production. So you work on a fix and definitely you add a test rate, so this error will not reoccur. But it will be hard for you to test this on production, as you fixed both the code and the test or added a new test. And you can be sure that the existing test didn't catch this issue as it went to production. But if you have tests written on this object store code, and you will test the new dev that will fix the prod soon, and your test will pass, so you know that dev is okay. If you run this code against production and prove that it fails, you will know that this test will catch the real issue. It doesn't only run and use this code, it verifies the problem. It's very hard to do this when you have one revision management and one version. It's hard to mix and match, and it's very good for testing. We use this rather often, and it's very simple to verify or show that a fix is good or resolves an issue, instead of just proving that it has test or coverage. Not everything is perfect, and working like this has some challenges. It requires investment in testing and the platform, as this is not standard. Some parts should be pre-deployed and aren't updated as fast as 1,000 times a day. This is actually what I'm speaking about, is the client, the Python. We update it frequently, but not 1,000 times a day. Let's say the dev environments are being updated twice a day. Well, we can support many environments and revision, but this might require a lot of disk space, as maybe you want the dependencies to change. Many different revisions of packages will require duplicate disk space, having packages stored a few times on disk. As everyone could use your code, it should be really robust, as your code could be hacked and used in many ways maybe you didn't expect while you wrote it. And if you are using this kind of continuous delivery and running from production, let's say you are migrating from Python 2 to Python 3, it can be a big bang migration. We have many processes. Monolithic code base has many entry points. So your code should support both Python 2 and Python 3 and work on both. You can't migrate, say, okay, I'm done with Python 3, no one will ever use me as Python 2. This also requires a lot of effort. And as our code base is really large, I think I didn't mention it before, it should be probably the largest Python code base in the world, having 14 million lines of code, something like that. Migrating from Python 2 to Python 3 requires a big effort, but we are using Python 3 in production, and we're good. Conclusions. Continuous delivery is possible at any scale, and also any scale of the code base, not only any scale of the production system. Automation, fast feedback lead to better culture and better products, and also a very good feedback loop. Things are much easier with Python, as the changes could be really small, and we don't have to build something big in order to make a change. It's not free, but it's worth it, definitely for us. A few references. First, about JPMorgan and JPMorgan in Israel. You are welcome to check our page and also look for opportunities on our site. These are references from Facebook and Google about monolith codebase. We are not the only one who are using it, and different companies are also using it in maybe a different way. Now we can go for questions, and also open the room for questions as part of the PyCon conference. You can look into the system. Thank you very much. I was Ben-Zeev from JPMorgan. Have a great day.